We have previously seen the limits and derivatives. Lot of things we have seen, but today we'll go into the detail, or you can say the more exemplified way to understand the derivative. We have seen the example of a rock, it is going or moving from one place to another, and how it is changing. The rate of change, we signified it or we indicated it through derivative. And there are so many life situation, real life situation, where you are going to find out that the derivatives are very helpful. Actually, these derivatives and limits, they are the core of further mathematics. The real definition of any derivative is this. What this means is that if f is a real valued function and a is any point in domain of this function, the derivative of f at certain point a is given by limit h tends to 0 f a plus h minus f a by h. This is only possible when the limit is existing. So the derivative of fx will be known. This is not complement, but this is f dash a. F dash a is the derivative of fx, and we'll try to see it through an example first, then you'll be understanding it more better. First is, you have to find a derivative at x equal to 2. So here a is 2 and the function f, this real valued function, is 3x. So we'll use this, you can say a relation or the derivation or the derivative f dash 2. This will be the derivative f dash 2. So f a plus h means please place x plus h at this place. So 3 into 2 plus h minus 3 into, because you have to place a here, and a in this case is 2. So f2 plus h minus f2 by h. So 3 into 2 plus h minus 3 into 2 by h. And when we solve it, we see that it is 3. So for any 3x, 3 can be taken as constant, and d by dx is nothing but the derivative, which is this only. D by dx and this expression is exactly similar. So for x, d by dx of x is 3 at x equal to 2, which is a here. Now you have to find out the derivative of this function 2x square plus 3x minus 5. Here the fx is this and a is minus 1. So the derivative of fx at x equal to minus 1 and x equal to 0, for this f dash minus 1 means you have to find out the minus 1, f dash at minus 1. You have to place minus 1 plus h, that is a plus h you have to place. So a is minus 1. f a plus h minus f a by h. Just place minus 1 plus h at all the locations where x is there, and you solve it. You solve it and h you can take common and place h equal to 0 or h tends to 0. When you are done with all the simplification, the answer will be minus 1. Because the question has also asked about f dash 0, so we will do in the similar fashion f0 plus h minus f0 by h. So 2 into 0 plus h whole square plus 3 into 0 plus h minus 5, and in this place x, everything is 0 by h. So the derivation of, or the derivative of this expression will be 3. And when we place these two values, you get 0. Okay, now the derivative of sin x. This is a trigonometric function, sin x. Sin x, similar way, f0 plus h means sin 0 plus h minus f0. You have to place a plus h and a here at the place of x minus sin 0 by h. And this is what? Sin 0 is 0, sin h by h, and we know that sin x by x, limit x tends to 0, gives you what? 1. Derivative of fx equal to 3 at x equal to 0 at x equal to 3. Now this is a constant function. Constant function, let us understand what exactly it means. So we are trying to find out the rate of change of the movement of the, say, a rock or a ball. But here, it is not a cliff. It is a plain floor and you want to move it. And just consider vacuum. So the rate of change will be nothing, because there will be no change. So the rate of change will be 0 always for any function which is constant. So fx equal to 3 is actually a constant. So even if you place f dash 0, f dash 3, so f0 plus h, you place this, it will be 3. You place this, it will be 3, because at every point this is going to give you a constant value. So 3 minus 3 by h, that is 0. Again 3 minus 3 by h equal to 0. So the geometric representation is like this, that you are trying to find out this angle. How? Let us see. At this point, say this point is what? X and y. So if x equal to a, then how you can find out y? Here, y, if x equal to a, y will be fa. So a and fa. If x equal to a plus h here, y will be equal to fa plus h. So these two coordinates are there. And if you want to find out the 10, this phi, 10 phi, this will be nothing but this distance by this distance, or the rate of change will be this distance by this distance. So this is what? This is the distance qr by pr, q tends to p. We want this distance to be as close as possible. Okay, p and q. So what you are getting exactly, f dash a, this one, and what you have got here is nothing but qr by pr, which is actually a tan of phi, or psi you can say. This is psi. So ultimately derivative is what? It is the tan. It is the tan, or the m, or the gradient, or the slope, or the rate of change. So everything which involves these words which I said just now is a derivative. Now we have say a relative real valued function fx plus h minus fx by h, and you want to find out f dash x, and I am now introducing d by dx. So d by dx of fx is nothing but f dash x only. So d by dx of fx is d by dx of fx is this only, right, at x equal to a. Now we have fx equal to 10x. Let us find out f dash x. Now what we are trying to do here is we are trying to generalize. Let us see. 10x, place x plus h here, not a plus. We are not finding out at any point say x equal to a. No, we are trying to generalize it. So let us take x plus h minus fx by h and limit h tends to 0. Place x plus h here and x this, and now x here. So 10x. 10x plus h minus 10x by h. How you are going to get it? Cancel it, 10. Here also fx is equal to x square. One time you place x plus h, one time you place x, so x square. Solve it, you get 2x. So x square d by dx of x square is nothing but 2x, which is nothing but nx to the power n minus 1. We are coming to this shortly. Now derivative of a constant function fx equal to a, it's quite simple. Fx plus h you put, it will be a. Fx you put, it will be equal to a. So a minus a is 0. 0 by h is 0. H should not be equal to 0. And you will say that h is tending to 0. So how can you say h is not 0? Because h is not 0. H is tending to 0. That is why limit says that this is true. Otherwise it would be 0 by 0. That will be infinite. How to find the derivative of 1 by x? Similarly, x plus h plus place x 1 by x plus h, then place 1 by x, and then just solve it, and you'll get minus 1 by x square after placing h equal to 0. H tends to 0 here. Algebra, if you want to add these two, you can take the derivative separately and add. If you want to take subtraction, you can do it separately. If you want to do multiplication now, there is a difference. First you have to take gx out and take the derivative of fx. Then you have to take fx out and take the derivative of gx. In a similar fashion, if it is u by v form or fx by gx form, so you have to square it first, take gx out and the derivative of fx, then fx out, derivative of gx, and then subtract them. So these are the expressions that you are going to use. So you can just view it very in a simplified manner. You can say that fx is my u, v is my say gx. So now uv dash, that is the derivative of u into v, will be nothing but uv dash plus v u dash. So u dash v plus v uv dash. These are called the Leibniz rule. So this is the Leibniz rule that you want to find out the derivative of ratio of two values u by v. So it will be nothing but u dash v minus uv dash by v square. Okay, and just try to imagine that you have to find out the derivative of 10x. What is 10x? What is 2x? X plus x. So 10x is what? X added 10 times. So d by df of x of fx will be d by dx of x, then x like this 10 times. And d by dx of x we have already found out that it is nothing but 1. If you find out using the first principle, it will be 1. So 1 plus 1 plus 1 10 times, it will give you 10. And in the similar, if you want to find out the derivative of this 10x, you can take 10 as the first function, x as the second function, that is fx, this will be gx. So uv dash will be u dash v plus uv dash, and you know how to find out the derivative, it will be 10. How about x square? X square can also be written as x into x. So let us find out d by dx of x take outside, and then take this x outside and d by dx of this now. Though they are same, so looking similar, but the fashion would be the way I said. It will be 2x. The derivative of x to the power n is nx to the power n minus 1. This is a very important relationship that we are going to see just now. By the first principle, the derivative function will be f dash x, which is equal to fx plus h minus fx by h. Let us place x plus h here, so it will be x plus h to the power n minus x to the power n by h. See, in this place, we can just open it through binomial theorem. NC0 x to the power n and this you know how to open it through binomial theorem. Now take this will be 1. Take x to the power n here. What all is remaining? Take h, because h will be there, h, and you'll get these values. Now you know that x plus this one, take derivative of this, x plus h to the power n minus x to the power n, and if you subtract it, you'll get this only, so you will place this. You can cancel h, only n x to the power n minus 1 will be remaining, else all will have h there, so they will become 0. So this will be n x to the power n minus 1. So if you have to find out x to the power n, it will be n x to the power n minus 1. Now there is another way also. The another way is x dot x to the power n minus 1, you can write x to the power 1 like this. So take x and d by dx of x, this constant is outside, and now this and derivative is x to the power n minus 1. We know that by induction hypothesis, this is going to be n minus 1 x to the power n minus 1. Okay, n x to the power n minus 1. Induction hypothesis. So this will x to the power n minus 1, and this will be nothing but this expression, and this will give you n x to the power n minus 1, which we earlier started. Derivative of polynomial. If this is a kind of polynomial, you can easily find out the derivative of the singleton values. For example, if you have 6x to the power 100 minus x to the power 55 plus x, but x to the power 100 is 100, x to the power 100 minus 1. So 100 x to the power 99. So 600 x to the power 99. Here 55 x to the power 54. 55 x to the power 54, and this will be 1. The derivative of fx will be of this. Take derivative of all of these. So this will be 0, this will be 1, 2x, 3x square like this. So this will be value. And see, when you solve it and place x equal to 1, you'll get this. And you know the sum of first n natural number is n plus 1 by 2, which is 50 into 51 by 2. That is 1275. How to take the derivative of this now? X plus 1 by x. This is your fx and this is your gx. So we'll use the Leibniz rule. U by v. This is the Leibniz rule. So u dash v minus uv dash by v square. U we have taken as x plus 1, v you have taken as x, and you can just take the derivative. This will be minus 1 by x square. The derivative of sin x, similarly, sin by first principle, sin f x plus h minus fx by h. Sin x plus h, you have to place x plus h here and then x here. So sin x plus h minus sin x by h. This is sin a minus sin b, which is actually 2 cos a plus b by 2 sin a minus b by So this is going to give you, let us take h by 2 here. This is going to give you 1. Place h equal to 0 here, and this is going to give you cos 1. How about tan x? Tan x, again, tan x plus h minus tan x by h using first principle derivative, and tan you can write it as sin x by cos x. H take outside. You have taken outside. When we solve it, we see that we got this, and this is nothing but the formula of sin a plus b, because sin a plus b is sin a cos b minus cos a sin b. So you can write these. You can cancel it out. Sin h by h is 1. This h equal to 0 you place cos x square. So this will be 1 by cos x square, which will be sec square x. How to compute the derivative of sin square x? You can take sin x and sin x individually. Use the Leibniz product rule. So sin x dash means derivative of sin x, then sin x, and sin x this one, and now derivative of this one. Because they are same, they are going to give you cos x sin x, that will be equal to 2 sin x cos x, which will be equal to sin 2x. So this was one more part of your derivative. We'll be taking one more, which will involve the miscellaneous and the summary. Thank you so much.